Hello friends, welcome back. Hearty welcome to you. In the last session, we have learned about what is integration and how to find out the integral of some simple functions. So let's try to have a recap of that before we move forward and try to learn about the methods of integration and especially in this session about integration by substitution. So what we have learned in the last session is nothing but integration, finding out integral of a function by inspection. Suppose we have been asked to find out what is the integral of cos x. What we did is we understood that integral is nothing but integration is nothing but anti-differentiation or exactly opposite of the differentiation. So I have to find out a function for which derivative is equal to cos x. D by dx of what is equal to cos x. If I am able to find that question mark is nothing but my integral. This is what we have done in the last session. Now we know that cos x will be derivative of sin x, because derivative of sin x is cos x. That means integral of cos x is equal to sin x plus c. The whole family of all the functions which have sin x plus a constant which can take any value. Okay, this is what we understood integration by inspection, and based on that we found the integral of lot of generally used functions. We found what is the integral of sin x, cos x, then we found secant x tan x, secant square x, cosecant square x, and we have found the integral of cosecant x cot x, integral of 1 by root of 1 minus x square. All that stuff we have found, but that may not be useful to us when we want to solve the generally given problem. So we have to look for tools or the methods to solve the integration, to say specifically to convert the given problem into one of the standard integrals whatever we have learned in the last session. So for that, one of the approaches used is integration by substitution. So let's take a simple example and try to understand with the help of that how we are using integration by substitution. Let us take a simple example to understand the concept. After that we will try to generalize it. Suppose I have been given find out the integral of x cube divided by x to the power of 4 plus 7, and you know I will have dx here, integral of that with okay, right. Now we have to find out the integration of this. Now any of the formula whatever we know only one formula, that integral of x to the power of n is equal to x to the power of n plus 1 by n plus 1 plus constant. This is the only thing we know. We don't know anything about this. Now what we do in integration by substitution is we will try to take part of our integrand. Integrand is nothing but the given problem, or x cube by x to the power 4 plus 7. We take part of this and try to substitute with another variable in such a way that this can be converted into one of the known integrals. Let's just do this. Now what you have to do is you always have to be careful when you are choosing your part of the function which you want it to be substituted with a variable, because you have to make sure that your derivative of whatever the function you are choosing, that should be also available with you in the integrand. So let us say, for example, suppose I take x to the power of 4 plus 7 is equal to t. Now what happens if I differentiate this? I will have 4x cube dx is equal to dt. Now what I can do by that, I'll just go back and say, if 4x cube dx equal to dt, can I write x cube dx is equal to dt by 4? Now I can keep that 4 outside. I can write 1 by 4, then I will have dt divided by x to the power 4 plus 7 is t. Now if you are able to understand how the given problem is converted into or transformed into a simple integral for which you know the answer already. So we know that 1 by 4 integral of dt by t is log of t. So we know that plus c. But what is the value of t? T is x to the power of 4 plus 7. So the answer will be 1 by 4 of log of x to the power of 4 plus 7 plus c. So this is basically the integration by substitution. What we do as part of that is we have to choose a part of the given function as another variable in such a way that the derivative of the given function will be nullified and the given problem is transformed into a known simple integral. Now if you look here, we have x to the power 4 plus 7, we have taken it as t. We got 4x cube dx equal to dt. So you have to look at always generally on the numerator side and see like what I should take so that this can be killed. If this can be removed, that means it becomes just 1 by t, and it's very easy. So you have to always think about how I can cancel this whatever the data in the numerator so that I can write it as 1 by t, so that we can go ahead with the integral of 1 by t as log of t. Let us do a couple of problems so that we'll get a hang of this. Let's look at this example. We have been asked to find out the integral of x into square root of x plus 2 into dx. Okay, now without any substitution, without doing anything, I don't know how to expand x plus 2 to the power of 1 by 2. So what I will do now, I will take x plus 2 is equal to t, because it's very easy to multiply t minus 2 into root t instead of x into root of x plus 2. That expansion is very difficult to do. Now what happens if I take x plus 2 is equal to, let us say something like t, then I will have dx is equal to dt. That means my next step will be, I'll go back and say integral of, that's equal to integral of, what is the value of x? X is t minus 2. So I can write it as t minus 2 multiply with root of x plus 2. Root of x plus 2 is nothing but t power 1 by 2. And what is dx? Dx is equal to dt. So we have converted now from x into t by substituting x plus 2 equal to t. That is method of substitution. Why we have done that? Because it's very difficult to find out what is square root of x plus 2, then multiply that and find out the integral of that. So we want to avoid this, so we have taken this as t such that I can write x equal to t minus 2. Now this is pretty easy because I know this is nothing but t into t power 1 by 2 minus 2 into t power 1 by 2. I have dt of that. That's nothing but equal to t into t to the power of 1 by 2 is t power 3 by 2 integral. I will separate them now and say dt of that minus 2 into integral of t to the power of 1 by 2 dt. Now what is the integral of t power 3 by 2? T power 3 by 2 integral is, let's do that here, t power 3 by 2 is, integral is t power 3 by 2 plus 1 by 3 by 2 plus 1. What is 3 by 2 plus 1? 5 by 2. So 5 by 2, 1 by 5 by 2 will be nothing but equal to 2 by 5. So I can write it as 2 by 5. I can write it as 2 by 5 t to the power of 5 by 2. Let me write it down. I can write it as this one, 2 by 5 t to the power of 5 by 2 minus 2 into t power 1 by 2. T power 1 by 2 is t power 1 by 2 plus 1, 1 by 2 plus 1 by 1 by 2 plus 1. That is 2 into 2 by 3, because 1 by 3 by 2 is 2 by 3, into t power 3 by 2. Now I can go back, once I have integrated it, I can go back and substitute the value of x again back. So it will become 2 by 5 into, we have plus c there, we will add it now. T is nothing but x plus 2. So 2 by 5 into x plus 2 whole to the power of 5 by 2 minus 4 by 3 into x plus 2 whole to the power of 3 by 2 plus c. So that's how we can solve this problem. Let's have a look at that again, what we have done with respect to that. We have been asked to find out the integral of x into square root of x plus 2. So we have taken x plus 2 is equal to t, then we have x equal to t minus 2, and root of x plus 2 is root 2. Now you expand them, then you apply the formula integral of x to the power of n is x to the power of n plus 1 by n plus 1. By applying that, you will get your answer as 2 by 5 into x plus 2 whole to the power of 5 by 2 minus 4 by 3 into x plus 2 whole to the power of 3 by 2 plus c. This is how we can solve the problems using substitution. Let's do couple of more problems. Let's look at one more example of the same type what we have solved earlier. We have been given to find out the integral of 4x plus 2 into square root of x square plus x plus 1. Now, if you remember, I told you always we have to look for that particular function for which the derivative is already available in the problem itself. Now I have 4x plus 2. Can I write it as 2 into 2x plus 1 into square root of x square plus x plus 1 into dx. Now if you observe very carefully, if I take x square plus x plus 1 as t, the derivative that will be nothing but 2x plus 1. So 2x plus 1 dx can be replaced by dt. So I'll go ahead with that. So that is how you have to do the suitable substitution. So let us say x square plus x plus 1 is equal to t. If you differentiate, you will have 2x plus 1 dx is equal to dt, or dt by dx equal to 2x plus 1. Okay. Now if you try to transform this from x into t, I will have 2 as it is. 2x plus 1 dx is taken away by dt, and square root of x square plus x plus 1 will become root t. Now you can see this became very simple. Now you know 2 into, what is the integral of t power 1 by 2? T power 1 by 2 integral is t power 1 by 2 plus 1 by 1 by 2 plus 1. That means 2 into 1 by 2 plus 1 is 3 by 2, 1 by 3 by 2 is 2 by 3 into t power 3 by 2 plus c, which is nothing but equal to 4 by 3 into t is nothing but x square plus x plus 1 whole to the power of 3 by 2 plus c. Now you can see without doing the substitution becomes very difficult. I don't know whether we have any way how we can find out the integral of this, because our general way of inspection will not help here, becomes very tedious. So we have to look for always try to simplify the given problem. That means part of the problem needs to be cancelled by the substitution. That's what we are trying to do if you observe always. Now we take a substitution in such a way that the part of the problem is simplified and the problem transforms into a known integral like root t, which is very easy to find out the integral. So integral of 4x plus 2 into square root of x square plus x plus 1 dx is nothing but equal to 4 by 3 into x square plus x plus 1 whole to the power of 3 by 2 plus c. Let's do one more problem. Let's look at this function. We have been asked to find out the integral of x cube minus 1 whole to the power of 1 by 3 into x to the power of 5 into dx. Now see here, always we have to look into that part of the problem which is very difficult to integrate. Now I see that x cube minus 1 whole to the power of 1 by 3 is very difficult to find out. So let us say we'll take x cube minus 1 is equal to t. What happens? 3x square dx will become dt. So let's just go ahead and substitute here. I will have integral of x cube minus 1, that is t to the power of 1 by 3 into x to the power of 5. I will write it as it is. Dx is nothing but dt by dt by 3x square. So can I say 1 by 3 into x square? Now x square will go x cube times, so it will become 1 by 3 into t power 1 by 3 into x cube is nothing but t plus 1 dt. Now you can see that how we have converted that into a known way of finding out the integral. So we don't know what to do with x cube minus 1 whole to the power of 1 by 3. So we have to always focus on, and another way you can see that if I differentiate I will get 3x square, and I can write x to the power of 5 as x cube into x square. That means I am getting derivative also already available. So we take x cube minus 1 equal to t. We will have t to the power of 1 by 3 x power 5 as it is. Dx is nothing but dt by 3x square. You simplify, you will get 1 by 3 into integral of t power 1 by 3 into t plus 1. Now this is pretty easy. We can write it as 1 by 3 integral of t power 4 by 3 plus 1 by 3 integral of t power 1 by 3. Now we know what is the integral of t power 4 by 3. That's nothing but t power 4 by 3 plus 1, that is t power 7 by 3 divided by 7 by 3 plus 1 by 3 into t power 4 by 3 divided by 4 by 3, which is nothing but equal to, now 7 by 3, 1 by 7 by 3 will become 3 by 7. So I'll have 1 by 7 t power 7 by 3. T is nothing but x cube minus 1 whole to the power of 7 by 3 plus, again 3 will cancel. I'll have 1 by 4 x cube minus 1 whole to the power of 4 by 3 plus constant. So that's the integral of x cube minus 1 whole to the power of 1 by 3 into x to the power 5 into dx. So what we do now, we took x cube minus 1 equal to t. We found 3x square dx is dt. So we substituted that. We got t power 1 by 3 into t plus 1, which is very easy to find out the integral, because we know integral of x power n is equal to x power n plus 1 by n plus 1 plus c. So we can leverage that formula and we can easily find out the solution. So in the next session we will do some more examples based on integration by substitution. I'll catch you again in the next session. Thanks for your time and support. Bye for now. Please do let me know your feedback. Bye.